Hello everyone, and welcome to Jam Academy. In this example, we want to show you how to apply the Work Kinetic Energy Theorem in a very interesting problem. Remember, work is the transfer of energy from one system to another. As a matter of fact, whenever work is done, energy is transferred. Now, by the Work Kinetic Energy Theorem, the net work done on a system is equal to the change in the kinetic energy of that system. In other words, the net effect of doing work on a system is the change in the kinetic energy of the system. Now, a car is moving with a constant speed v along a horizontal road, encounters a long, rough, horizontal patch of road with a coefficient of kinetic friction mu between the tires and the road. How far does the car travel on this patch of road before stopping? Now, we're going to use the Work Kinetic Energy Theorem in analyzing this problem. Step 1 in applying the Work Kinetic Energy Theorem is to choose two appropriate points, the initial point and the final point. Now, we will choose our initial point A and our final point B. The final point is where the car comes to a stop. The initial point is the point where the car enters the rough patch of road. By virtue of the Work Kinetic Energy Theorem, the net work is equal to the change in the kinetic energy of the car, which is just the final kinetic energy minus the initial kinetic energy kBA. But the question is, how do we calculate this? Quite easily, the final kinetic energy is just 1/2 mVb squared minus 1/2 mVa squared. The good news is the final speed is 0. So this would mean that the net work done is equal to negative 1/2 mVa squared, which is just mv squared. So step 2 is for us to calculate the net work done on the object. In order for us to calculate the net work done on the object, we need to know the forces acting on the object. To know the forces acting on the object, my recommendation for you is to draw a free body diagram. A free body diagram is a diagram that shows us the forces acting on the car. We are assuming that the car is moving along the rough patch of road. So the free body diagram itself, you will have the weight of the car downwards. You will have the normal force acting vertically upwards. Then you will have friction. This is kinetic friction. There is no traction force pulling the car forward. So in this particular case, what next do we do? You can clearly see that the sum of forces along the y direction is 0, which means that Fn is just going to be equal to mg. Also, by definition, f of k is going to be equal to mu Fn, which is just going to be equal to mu mg. So let's take note of these two scenarios. So the net work done on the object, Fnet, is going to be equal to the work done by friction, which is f of k, multiplied by the distance moved, d, cosine of theta. Now, what is theta? The displacement is to the right, the force of friction is to the left, so the angle is 180 degrees. So this is 180 degrees. And that will give us negative mu mg multiplied by d. And if that is the case, we therefore have negative mu mg d is equal to 1/2 mv squared. The good thing is that the m's on both sides of the equation can quickly be erased. And if the m on both sides of the equation can quickly be erased, we've been asked to calculate d. We then can say that d will be equal to v squared divided by 2 mu g. So this is the distance traveled by the car before coming to rest. V squared over 2 mu g. Now, this is quite an interesting problem, and I'm having a lot of fun doing this. If you have any problems or difficulties analyzing or understanding these problems, please, and I mean this, let me know by, commenting or participating in the discussion forum below this video. Thank you so much and have a wonderful day. Remain blessed. Bye-bye.